Uh, Somebody asked a question on technology for home heating, cooling, and hot water. My name is Marcia Cooper, and I hope you are still all staying very safe, hanging in there during this challenging time. In this presentation, Dr. Philip Hanser and Craig Foreman will discuss applications of heat pumps and mini-split heat pump systems. You will learn how heat pumps work, what types of equipment are available, and where they might be most useful. The speakers will also discuss heat pump water heaters. To tell you a little bit about our speakers, Dr. Hanser is our first speaker. He has nearly 4 decades of consulting experience in the energy industry and has held teaching positions at Harvard and Columbia universities. Craig Foreman, our second speaker, is a Green Newton board member who has led our Newton Go Solar program. And he is the lead coach for Newton's newly launched initiative for the promotion of heat pump technology. We will also be, our third panelist is Beverly Craig. She will be handling the Q&A part of this program. And Bev is project director at Mass Clean Action Center. That's probably not absolutely the correct title, but Bev and Craig are Green Newton board members who do tremendous work. For those of you who've dialed in, you will be in listen-only mode. If you are using your mobile device or a laptop, you may use the toolbar on your screen and choose speaker views. If you do not see the toolbar, you can tap the screen with your finger or move your cursor to access it. Some screens, it's at the very top corner on the right. And other, I think in some instances, it may be on the bottom.
Marcia, I don't think they'll see that speaker view option. They're just going to see the presentation and a picture on the right, and they can slide that. You can tell them about sliding that over.
Oh, okay. Thank you, Craig. If you do, when we share a slide, you will see a split screen with the presentation on the left, which is probably what you're seeing right now, and the speaker on the right. If you want to view the slides larger and speaker smaller, you can drag the vertical bar in the center right side of the slide. You drag it to the right, and you can make the screen, the slide bigger and the speaker a little bit smaller. Don't make me too much smaller. Get it? Okay, I couldn't resist. We will be using the Q&A button for questions. Green Newton board member, as I said, Bev Craig, will facilitate that part of our program after the slide presentation. And again, you can submit questions during the webinar to be addressed at the end of the presentations. If you are experiencing any difficulty whatsoever, please use the raise hand button or the chat function to let us know, and we can help you to resolve any issues. This webinar, remember, is going to be recorded so we can share it after tonight. So no need to take any notes. I said at the beginning of this that nearly 100 people signed up for the webinar. Some people may be joining us later. And so far we have 65 participants. And now it is my great pleasure to introduce you to Dr. Philip Hanser, who will begin the slide presentation. If all goes as smoothly as planned.
Hi, let's see. So let me begin. First, let me say thank you to Marcia for introducing me. I would be remiss if I didn't tell you that my current employer is Boston University, so I want to make sure I said that. You know, on this lovely rainy, cold night, it's nice that you want to warm yourself by a heat pump presentation. Oh, never mind. Okay, so what we're going to do is talk about heat pumps tonight. We're going to primarily talk about heat pump water heaters and heat pumps that will be used for heating and cooling your home. And these are sort of pictures of some applications. Please feel free to just, you know, raise your hand if you've got a question. We'll try to take questions basically at the end, but if there's something really urgent, please let us know, raise your hand, and we'll try to answer them. First, I have to begin by a shout out to Marcia Cooper and Bev Craig and Mike Ductless, Craig Foreman and Jonathan Cantor. They've all been very assistive, provided great assistance to me, but of course, anything, all remaining errors are mine. So how does the question of heat pumps actually arise? I mean, it really arise because people have questions. You know, I'm adding a room to my house, should I put a radiator in it? Which means I have to add additional gas capability to my house. You know, what can I do about air conditioning during the summer? I have a lovely attic that I've got, you know, windows and everything else. It's unbearably hot though during the summer, and I can't use it. You know, it has lovely views, as many attics do. Is there anything that I can do to make it more useful to me? We're renovating our home to accommodate my in-laws. I'm sure all of you are becoming, what is it? What's the word? The sandwich generation, right? You've got both children and likely to have your parents at home at the same time. They're always complaining about how it's too cold. If we heat the whole house, we'll all boil and the children will run out of it. So is there anything that we can do to basically address that question? And so the answer turns out to be heat pumps. Heat pump technology has great capabilities to provide very specific heating requirements and cooling in parts of your home. And we also have the possibility of heat pump water heaters, which are a gasless alternative to heating water, and that turns out to be quite efficient. By the way, I do want to point out in a couple of these pictures, some of the air handlers, which is, I don't know whether you can see this, but this kind of white thing hanging off the wall, I wouldn't recommend positioning an air handler directly over your furniture, like your living room couch or your bed. You really want to think about heating and cooling the room rather than trying to heat or cool your couch, because in the end, what you'll do is you might find yourself freezing or boiling, and you wouldn't find that very comfortable. So I apologize in advance if some of these slides really show a positioning of the air handler that I wouldn't really recommend. So let's just talk a little bit about how heat pumps work. Somebody raised the question already, you know, is your refrigerator a kind of heat pump? And the answer is, yeah, it is a kind of a heat pump. Essentially, what does a refrigerator do? It transfers heat from inside the refrigerator, right, to cool your food, and transfers it to the outside. Well, a heat pump is, in a way, for heating your home, you know, or cooling it, does exactly the same thing. The heat pump during the summer transfers heat from inside your home to the outside. During the winter, it essentially transfers heat from the outside to the inside of your home. I know it sounds sort of hard to believe that you could actually transfer heat from the outside into your home during the winter, but trust me, you really can, okay? Most heat pumps that we typically see are air source heat pumps. The most common one is a mini split. And in a mini split, basically you're looking at a more individualized kind of unit. We do see some ground source heat pumps, although ground source heat pumps tend to be new installations, because in essence, I have to put some form of piping of one form or another into the ground. Either in this case, you can see a picture where it's horizontal. It's going to be laid horizontally in the ground, or alternatively, it's vertical. And that requires basically a drill rig on your property and so on, and quite some customized engineering. So why are we interested in heat pumps? And the answer is it's because heat pumps have become sufficiently advanced that even in the cold climate of New England, they can provide heating and cooling year-round and be efficient. And particularly, we are interested in, you want to think about a heat pump after you've weatherized and sealed your home. So why are we also interested in heat pumps? Because heat pumps in the long run provides us a mechanism, as well as all kinds of electrification will, to lower greenhouse gases. So the blue bars is basically where we are in terms of greenhouse gases emissions for heating. It's just an example home. And you can sort of see that even nowadays, a heat pump, an air heat pump or a ground heat pump generates much less greenhouse gases than either electric baseboard, oil, or natural gas. If, on the other hand, we get to the point where in 2050, we really have renewables dominating the way in which we are receiving electricity, then in fact what happens is, and you can see, essentially greenhouse gases go to zero for both the air and the heat pump, and the ground heat pump, whereas for natural gas and oil, they remain high. So electrification provides a mechanism to get to a lower greenhouse gas emissions.
So you had start
Heat pump myths.
you had start poll 1 there. On
Oh,
that,
I'm sorry, poll 1. I'm sorry. Can you put up poll 1? My apologies.
why don't you read the
So it says, today's heat pumps for heating and cooling can provide comfortable heating down to outside temperatures of 32 degrees Fahrenheit, 0 degrees Fahrenheit, 15 degrees below 0 Fahrenheit, and finally 30 degrees below 0 Fahrenheit. So which do you think? Are people voting, I hope?
Yes.
Okay. Can you put up the answers?
We have 44 of 45. Why don't we give people another few seconds
Okay.
to vote? Okay, that was a few seconds. I'm going to end the polling and we'll share the results.
Ah. So the majority of you got it right, that heat pumps can actually operate to reasonably efficiently to 15 degrees below 0. You can even go lower, and we'll talk a little bit about that next. So here are some common heat pump myths. First, that electric heat is inefficient, that heat pumps can't work in the Massachusetts climate, and that heat pumps cannot serve as the only source of heat in a home. So electric heat is inefficient. So air source heat pumps can get to as much as 350% efficiency at their maximum. On the other hand, a ground source heat pump is at least 350% efficient and can get almost to 5 times as efficient as electric baseboard heat or any other kind of resistance heat. So air source and ground source heat pumps can be very efficient. Secondly, heat pumps don't work in the Massachusetts climate. Well, in fact, the cold climate air source heat pump specification for NEEP requires high efficiency to 5 degrees, and many systems perform to -13 to -22 degrees. So the heat pump systems provide efficiency at very, very low temperatures and continue to heat even at temperatures like that, even if they're not as efficient. Finally, heat pumps cannot serve as the only source of heat in a home. In 2017, about 10% of new homes in Massachusetts use as a heat pump as the only source of heating and cooling. And ground source heat pumps do not lose output and efficiency significantly, even on the coldest days of the year. And dozens of systems have been installed through Mass CEC programs, and retrofits had no backup heat at all. So electric heat can be efficient, heat pumps can work in Massachusetts climates, and heat pumps can serve as the only source of heat in home. Here is we're going to talk about heat pump systems now. This is a central air source ducted heat pump system. This is a system in which if you already had air conditioning ducting and you had an air conditioning system nearing the end of its life, you might want to consider using. The next kind of system to talk about is a ductless mini split system. You can sort of see that in this home on the right, they've got they have a ductless system that operating in every room of the house essentially to provide whole house heating and cooling. again, I'm not saying this picture is necessarily represented, the one on the left, of where you want to put your air handler for your system, because it's directly over where you would be sitting. So every ductless mini split system basically has two components. It has an outdoor compressor unit, and it has an indoor unit. They're connected by refrigerator lines that are on the outside of your home, and then connect into the back end of the indoor unit. And this is what the indoor unit looks like if you take off the cover. I'm not recommending that you do that, by the way. Better to have your air conditioner specialist do. But here are the component parts. There's a heat exchanger that basically is the mechanism by which the heat will be transferred or removed from the home. There are air turning vanes. In this case, you can sort of see that the air turning vanes are actually split. That allows you to have more than a single direction for the air to be sent through. And then lastly, there's a blower that sits behind the vanes that blows the airs through the vanes. Many vanes have a mechanism that basically rotates the vanes on a periodic basis, but you can also simply set the vanes in a particular direction if you want. Here's another kind of mini split system. In this one, the air handler actually sits in attic space or someplace like that. And then you can see on the right-hand side that there are vents where the air handler is providing the air through a set of ducting. And you can see the ducting in the aluminum foil wrapped piping. Often you'll see more than one type in a home. For example, you might find mini split heat pumps on the first floor, and you might find ducted systems on the second floor. The reason you might see that is because you have the attic space in which to use the ducting, whereas the ducting might be difficult to introduce into the first floor. There are many indoor kinds of looks. The typical one is the one in the upper left-hand corner. It's a wall-mounted. It's probably the most traditional and most popular. But there are floor-mounted units. There are cassette units that typically sit in the center of the ceiling. And there are slim ducts that typically will sit on the side of a wall, much like we showed before.
We have poll 5.
Oh, did I miss it? I'm sorry. I put it in there. Yes. What do you see as the biggest benefit of heat pumps for heating and cooling? Eliminating gas or oil for heating. Eliminate the need to use bulky window air conditioners. Save money in operating costs for heating and cooling. Ability to heat and cool with one system. Allow my house to become 100% electric.
We'll allow a minute for you to make your choices. About another 20 seconds. Okay, we're going to end the polling. Here we go. And I'm going to share the results.
Well, I like to see the environmental consciousness of people, which is great. I'm also assuming that the folks who are on the bottom that's saying allow my home to be 100% electric are similarly driven by environmental concerns. So, bravo. So, you may want to consider heat pumps if you're heating with oil or propane or electric resistance and you want to save on your bill. You could save lots of money. That may not be true with a whole home retrofit with gas, at least with energy prices in 2020. But on the other hand, you will have eliminated a large source of greenhouse gases from your home. You also may want to consider a mini split if your current air conditioner system looks like the unit in the upper right-hand corner. I run through Newton quite often, and I will tell you that I see lots of these ugly, I'm sorry, I shouldn't probably use that term, but unattractive, how should we say, room air conditioners that sit in people's windows. And I don't know about you, but my old window air conditioners used to be noisy. And I can assure you the mini split that you would put in to replace this is not noisy. It's both quiet on the outside and it's quiet on the inside. And it's the capability to handle air in a way that makes the room extremely pleasant. In addition to which, of course, you can use it during the winter to heat the room. You may want to think about heat pumps if you've got one big area you want to start with, and you may think about wanting to add one over time. You don't have to replace your whole system. Here's that attic space that is upstairs. Maybe this is for grandma and grandpa who's going to be joining you, or for the extra set of kids that you didn't expect to have. But in any event, here's the space for them, and this is the perfect area to think about putting in a heat pump. And of course, you can use, because of the nature of the heat pump, you can zone it. That is to say, the temperature at which it operates for each of the zones can be different depending on where it's located. Heat pump costs. So the average cost for a heat pump for a mini split is about $3,500 to $5,000 per zone. For a ductless cold climate air source system, it's about $10,000 to $18,000 system if you wanted to retrofit a ducted system with air source. And if you want to do a whole house air system with non-ducted mini splits, it's probably talking about $18,000 to $24,000. Craig, after my little talk here, will talk all about opportunities for rebates and other ways in which to reduce that first cost, and also about help so as to find that. There are other considerations you may want to think about. You may need to upgrade your electrical service. And if you do, you may want to think about electrifying, upgrading to the point where you could also install an EV, charge an EV. You have to make sure that your installation needs to ensure that the outside compressor isn't going to be buried in the snow during the winter. And you can sort of see how this installation on the right has a platform that the compressor sits on that pretty much guarantees that won't happen. Proper installation is critical. It's important, if you can, to get whoever is the installer to do an appropriate set of heat load calculations so that the compressor and the various air handlers are appropriately sized. You'd like to have good air sealing because to get the most out of the units and at their most economical, you really want to have your home well sealed and well insulated. You don't quite operate this like a fossil fuel system. There's no setting back because mini splits take more time to recover their temperature. But an appropriately sized and installed system, that will not be an issue. So let's talk a little bit about heat pump water heaters, which have really actually come down in cost and become much more accessible. So just like heat pumps move heat from one place to another, in this case, a heat pump water heater basically moves heat from the outside in your home into, in fact, the water heater. And that transfer of heat from your home into the water heater heats the water. Most of heat pump water heaters are sort of hybrid in the sense that not only do they have a heat pump, but they also have typically an electric resistance coil as a backup in case there's some issue associated with the heat pump operating. And here are 3 units, Rheem, Rudd, Bradford White, and A.O. Smith. They're all now pretty much typically sized as other standard water heaters. Benefits. They're high efficiency and they can provide cost savings against non-gas water heaters like electric water heaters. They will reduce greenhouse gases by avoiding fossil fuel uses. If you have some solar panels, those will offset the cost of both the hot water heater and as well as the heat pump for cooling and heating your home. It can dehumidify your space. And the installation is essentially identical to that of a conventional hot water heater. There is an option for providing domestic hot water heater where a combination boiler is replaced by a heat pump. And now there's even built-in leak detection that will automatically shut off the hot water heater and send you a text message. So if you have a phone, a smartphone of some sort, I can't imagine that anybody in the audience is still walking around with a Motorola flip phone from the 70s. Maybe it was the 80s. It'll be able to tell you whether or not you've got a problem. Just some considerations for installation. You do have to have a suitable space. You will have to have an area in which to drain the condensate that arises from it. It's best if you can to put it in a semi or unconditioned space to minimize the impact on space and comfort. And the room should remain above 55 degrees to remain consistent and have efficient heat pump operation. And of course, as before with the heat pump, you may need to have some electrical work if the previous previous water heater wasn't electric. Conclusions. All right. Heat pumps can be, for space and water conditioning, can be a way to get fossil fuels out of your home and reduce your impact on the climate. We think, and we strongly believe, electrification of our energy uses appears to be the best way to risk global climate change. The quality of the installation of both the heat pumps and for heating and cooling and for the water heater is crucial to achieving the energy savings. An assessment of your home's weatherization is a useful first step. Craig will talk a little bit about those opportunities. And you'll want to use a contractor with heat pump experience and who understands and designs with heat load calculations. Again, HeatSmart is a mechanism from the city of Newton that's aimed to provide you assistance in all of those sorts of things. Poll 4. So poll 4 is, what is your biggest concern about installing heat pumps for heating and cooling? Don't know what installer to use? Not sure they work in our cold weather? Don't want to make a mistake doing this? Too expensive to operate? Too expensive to purchase and install? Don't understand how they work? I'm not sure this presentation helps you with the last question.
We'll give you another 10 seconds to answer. Okay, we're going to end the polling now. I'm going to share the results.
Well, I must have been extraordinarily successful because only 2% of you say they don't understand how they work. Well, that's unbelievable. Will you do a teacher evaluation for me? No, never mind. Well, I think the question about purchase and installation is going to be addressed by Craig. There are lots and lots of programs out there to help you defray those costs. Craig is going to come up and tell you all about HeatSmart and all the good programs that are going to help to do that. So I'm going to close this off and I'm going to stop sharing my screen and allow Craig to share his screen.
Thank you, Dr. Hanser, for a great introduction to the technology. And I am going to now start to share my screen. And we're going to bring this, and also thank you everybody for joining tonight and spending the time and listening to this and hearing about heat pump technology. As we go through this presentation, if you have any questions, remember, just type them into the Q&A and we will get to them at the end. I'm going to talk more about heat pump technology, but before I do, I'm going to kind of bring it back to a more local level and talk about some things have been done in Newton and some things we're going to do in Newton, and we'll get back to heat pumps in a little bit. I'm going to introduce a really exciting program that we have starting here in Newton. So when we talk about replacing fossil fuel with electric heat pumps, we really have to understand that we're now moving from fossil fuel as an energy source to electricity. And it's very important that understand that we're going to be using more electricity. So we want to make sure that the electricity that we're using is not itself powered by power plants running on fossil fuels like natural gas or coal or something like that. So when we start using more electricity in our homes, we want to try to make sure that the electricity that we're using is backed by 100% green sources. We're really very lucky in Newton because we've got Newton Power Choice. If you're not in Newton, your towns may have a similar, what we call aggregation program. But in Newton, we have Newton Power Choice, and our default is 60%, backed by 60% green renewable energy. The state mandate right now is only 20%. So if you haven't opted up to 100% yet, you really should think about it. It's very inexpensive. In fact, the price for opting up to 100% green for your supplier cost of electricity is now actually less than the supplier cost if you weren't in the Newton Power Choice program and you were getting your supply directly from Eversource. So it's very inexpensive. And if you haven't already done this, please consider doing that. Because if you do, you can do all the electrification you want. And if you're getting your electricity from sources that aren't backed by 100% green renewables, you're really not getting all the advantages that you should. And as we start to use more electricity, of course, we're going to have to pay for it. If it's possible, if you have a good site, that means you've got a clear roof area that's not shaded and it's facing, in a decent direction, think about going solar. We still have great tax credits. They're actually going to drop significantly at the end of 2020. So now is still a really good time to go solar. Green Newton has run 3 solar programs. We're very familiar with solar. If you have any questions about how to go to solar or who to use, please email Green Newton and we can help you with that. The other thing that you should consider is that whenever we start to put heat pumps in for heating and cooling, we have to think about insulating our houses first. By insulating your house, insulating it better, you're going to reduce the energy load and you're going to be able to reduce the size of the heating and cooling system that you put in. Now, there's a program, which I know all you know about, where you can get a free home energy assessment. It's a mass save program. You can do this every 2 years. You get lots of free stuff, and they will typically give a 75% discount on any installation that they do. Now, just today, I got word that there is a change being made because most of the home performance contractors who do this are not going into homes right now because of the pandemic. So they're now doing virtual assessments. That means that you're going to send them pictures of your house and they're going to go to the assessors for records so they can get an idea of what your house is like. And they can actually do this virtually. And at least for a limited time, you are now going to be able to get 100% discounts on any installation that they recommend, which means you're getting installation free. It's not any kind of installation. It's just the ones that they have access to and the ones that they do. Now, Green Newton has partnered with a company called HomeWorks Energy, which is a home performance contractor. You can go to any mass save contractor mass save partner that you want to, but this is just one that we've worked with. We know they'll do a great job, and they will give us a small donation for every completed home energy assessment. It's easy to get to. You can go on to the Green Newton website and click on the right side of the page and sign up for an assessment, or you can call them, select option 2, and please mention that Green Newton sent you. And like I say, they won't schedule any assessments in your home until at least May 4th right now. But if you want to schedule something, they will schedule a virtual assessment if you want to do it that way, and you'll get that extra discount on your installation if you choose to do that. Now, I want to talk about something that's been worked on for a few years called the Newton Climate Action Plan. I'm sure many of you know about it. This is not a plan that was done by city personnel. It was done by city personnel with the help of many citizens committees and many people that are probably on this webinar tonight. And I thank everyone for their effort. It was a huge effort. This is a 121-page plan. And the slogan here is, use less and green the rest. It's a great slogan. And I want to give a call out to the Newton mothers out front who created that slogan. It is a 5-year plan, but it really looks out way more than 5 years. It looks out to the year 2050, and it's trying to set us up to see how can we get to carbon neutrality by 2050. You can't get there if you don't start somewhere, and start now. And so there's all kinds of plans and goals in this plan, and these are not mandates, they're not laws, they're plans. And we will try to meet these plans. There's things we have to measure, there's things we have to do, and there's a lot of things along the way that will help us know if we're meeting our plan. And Marcia, if you could start poll number 2 right now. This poll is looking out 3 years to the year 2023. And the poll is about how many heat pumps should we be doing annually in the year 2023, which is 3 years from now. So Marcia, can you put up that poll? It's poll number 2.
Oh.
Yeah, there we go. So how many do we expect that we should be doing annually in 2023? And the choices are 100, 250, 450, or 1,000. Now keep in mind that there's about 30,000 residential units in the city of Newton. And this is just for that 1 year of 2023.
Okay, another 15 seconds. Okay.
And the reveal. And we've got some really aggressive thinking people that the majority said we'd like to be doing 1,000 by the year 2023, and that would be dynamite. The Climate Action Plan actually calls for 450 a year by the year 2023, but hopefully by kickstarting these efforts with programs like I'm going to introduce tonight, maybe we can get to 1,000 a year by the year 2023. That'll just get us to carbon neutrality earlier than 2050, which would be great. Thanks, Marcia. Okay, in the Newton Climate Action Plan, there's a breakdown of where our greenhouse gas emissions in Newton are coming from. And there's a pie chart you can see here. And I want you to concentrate on the 2 green sections of the pie chart, because those are the sections that are coming from the 2 big residential sources. On the bottom, you have the passenger vehicles. 24% greenhouse gas emissions are coming from that. And up on top of that, you see 35% of our greenhouse gas emissions are coming from residential buildings. That would be your homes. Total together, that's 59%. That's a big number. So let's look at the bottom one, which was 24%, which was the greenhouse gas emissions from residential vehicles. We know how to fix this. The best way to fix it is to walk, bike, or take public transportation. But of course, we can't always do that, and people are always going to have cars. So there's another way we can fix it, and we all know what that is. It involves getting rid of that tailpipe, getting rid of those emissions, and going to an electric vehicle. And hopefully, when we charge it, we're charging it from an electricity source that's 100% green. Now, if we look at the other big one, which was 35% of our total, that's residential buildings. And if we drill down further to see what's in there, we see that 61% of that is heating and cooling, 17% is hot water, 2% are, and this would be for a typical gas home, would be clothes dryers, and there's an other section of 20%, which would probably be things like gas cooking, maybe gas fireplaces, using propane to barbecue. But 80% of what you see here, that would be heating and cooling, hot water, and the clothes dryers, can actually be done with heat pump technology. And we didn't talk about heat pump clothes dryers, and we're not going to talk about it. But heating and cooling and hot water are the big ones here that we can tackle through heat pumps. So how do we fix this? Okay, in a picture, here's how we can fix it. So this is my poor little house in Newton with a gas-fired hot water heater and a gas-fired furnace. And I got no air conditioning, so I'm really hot in the summer. What do? Well, if I get heat pump, heating and cooling, I eliminate all those emissions coming from my hot water heater and coming from my furnace. And I get air conditioning for free. So I'm really happy now because not only am I not generating all those emissions, but I'm cool and comfortable in the summer now. Now, if we want to go a little further, if we can, we might think about putting solar panels on. Now I have a way to actually pay for the electricity, the extra electricity that I'm using that I wasn't using before. And if I want to be real aggressive, and this is not the easiest thing to do, I have a chimney now that's not really needed. There are ways you can actually remove the chimney. You can take it down and it's going to go all the way down through your house into the basement. It's not a structural component of your house. Many people have done this and reclaimed the space, and you can enlarge your kitchen. You can open up rooms. It's amazing what you can do if you want to do that. Okay. So now I'm in. Oh, yes, we have a poll. Marcia, could you please bring up poll number 3? And poll number 3 says, what does Newton's climate action plan suggest as a goal for the total Newton residences with heat pump installations by the year 2050? Now, this is not how many we do in that year. This is how many total we have done by that year. And keep in mind, we have around 30,000 residences, residential units in the city. So your choices are 1,000, 5,000, 10,000, or essentially all homes by 2050.
Okay, we'll give you another few seconds. 5, 4, 3, 2, 1. Here we go.
And okay, we have a very aggressive and very smart audience here because you are correct. The majority of you voted that we want to have all homes using heat pumps by the year 2050. That is the goal stated in the Climate Action Plan. Thank you. So how are we going to get all 30,000 homes in Newton to adopt heat pump technology? Some would say this is impossible, it's not going to happen. But when you think about it, think about replacement cycles. How often do you replace your hot water heater? Well, you're going to replace your hot water heater probably every 5 to 7 years. And you're going to replace your furnace probably every 20, 25 years. So there is several replacement cycles of hot water heaters before the year 2050. And there's at least one replacement of everybody's heating and cooling system by the year 2050. So if we plan now and we think smart, we can get there and we can do this and we can have all our residences converted to efficient electric heat pump technology by the year 2050. So this is a program that we're launching. This is a City of Newton program. It's not a Green Newton program. And we call it HeatSmart Newton. Now our logo says HeatSmart, Cool Smart. And that's just to remind everybody that when you do heat pumps for heating and cooling, you're not only getting a utility that heats your home, but it cools as well. You kind of get that for free when you install the system. And this program is really all about educating the residents of Newton about heat pump technology and making it easy for them, or at least easier for them to adopt the technology. So it is a City of Newton program. The City of Newton received a grant to promote this, but the city is not working alone on this. Much like the effort that we did when we did the Power Choice program, the City of Newton is working in conjunction with 3 very strong volunteer groups in Newton, being Green Newton, Newton Mothers Out Front, and 350 Mass Newton Node. These volunteer organizations are the organizations that are really going to get the message out to the people of Newton about what we're doing and what's available. So what is HeatSmart and where has it been? Okay, HeatSmart is a community-based education and a group purchasing program to accelerate the adoption of clean energy technologies. The program is actually managed by two agencies, state agencies, one called the Mass Clean Energy Center, which we call the CEC, and the other one being the DOER, which is the Mass Department of Energy Resources. Now what you're seeing on the map here is a map of the HeatSmart programs that have already finished. This is the third year of HeatSmart. These programs were all done in the past, in the 2 years prior to this year. There's a total of 13 communities that have done this. Now, you don't see 13 bullets here, you see less. That's because some communities get together, if they're small towns, like there's one that says Carlisle, Concord, Lincoln. They got together and did one HeatSmart program for all 3 towns. And you can see that these programs have been all the way from Great Barrington in Western Mass to Nantucket. This year, there were 2 recipients of grants. Newton was one, and the other one was Melrose. So how is this program, HeatSmart, going to benefit Newton? Well, we're going to educate the community, and we're starting tonight, about electrification of the home in general. And specifically, we're going to help people understand the benefits of efficient heat pump technology. And we're going to encourage the adoption of this technology in our homes. We're going to be able to connect you with vetted, reliable, knowledgeable installers who you can trust. Now, this is a bit of a problem right now during the pandemic because our installers are not able to go into people's homes. Some installers are just doing emergency business, and this has kind of set our timeline back a little bit. So right now we're concentrating more on the education piece. But as soon as we get out of this, this social distancing, we will have vetted, reliable installers, and we'll let you know who they are so that if you want to use our suggested installers, you'll have someone that you can certainly trust. By doing this, we hope to squeeze a little bit of time and a little bit of cost out of your project because these contracts will be negotiated with the installers that we choose to partner with. And we find that once you begin to install technology in your home, whether it's heat pump hot water heaters or heat pump heating and cooling, your neighbors kind of find out about it and they kind of get interested and ask you questions. And we see neighborhoods start to develop more installations as people see what their neighbors are doing. It's a very important part of the program. All right, so let's talk about what technology that we're going to offer in our HeatSmart program in Newton. We have chosen 2 technologies to offer. The first one is air source heat pumps for heating and cooling. This is what Phil had talked about. And specifically, we're going to offer ductless mini splits, which could be a single zone where you have a single compressor and a single air unit on a wall or on a ceiling in your house. Or it could be a multi-zone system where you have a compressor serving a couple of rooms, and those are both ductless systems. We will also be offering a central ducted system. If you want to do your whole house or a whole floor of a house, and you have ducting already there that might be used now for a heating system, if that ducting can be reused, we can convert that, we can put in a central ducted system and reuse that. That will be part of our offering for technology number 1, which is heat pumps for heating and cooling. Technology number 2 is for heat pump hybrid hot water heaters. And Phil talked about this. They're hybrid because in order to kind of match the performance of conventional hot water heaters, like you take 3 showers in a row or something, they have an electric heating capability built in that they can turn on if they need to. But for the most part, these will work in HeatSmart mode. They're very smart systems. There's settings. Everything's done by Wi-Fi. You can control them or change the temperature in your house from a smartphone anywhere in the world. It's really a great technology. Now, you've seen a lot about the technology, and it's very important to think about the fact that you don't need to go and do everything at once. You can start small and then get bigger. For instance, you could start with a single mini split with 1 or more heads and maybe add more later. You could put a heat pump in a large open area of your home and see how it affects your comfort in this area and other adjacent rooms, and later add more if you want to. You might want to start with a heat pump hot water heater. And you can then increase coverage of your system as you get more comfortable with the technology. But remember, the more heating and cooling you're going to do with heat pumps, the more important it becomes to actually improve your installation. That allows you to use less electricity and allows you to install a much smaller sized heat pump system. So the question becomes, how do you finance such a thing? Fortunately, we have what we call the 0% heat loans. These are very commonly available by many, many banks. It allows you to borrow up to $25,000 for a project like this at 0% for 7 years. There's some additional benefits available for low-income residents, and there's a table here of what that low income would mean. But if you are a low-income resident and you're upgrading from what we call conventional electric resistance heating, you can actually get 100% free weatherization, replacement of inefficient appliances, and absolutely free heat pump heating and cooling if you fall under these low income categories. But there's also rebates and financial incentives that many or everyone can take advantage of. And I'm just going to quickly go over these. We have mass save rebates, which we are all eligible for these. For the air source heat pumps, they're based on the size of the system you put in. The biggest rebates you're going to get with this program are going to be if you're replacing an oil heating system or propane or electric resistance heating. The rebates for replacing a gas heating system are smaller. On the heat pump hot water heater side, there's an excellent rebate right now. If you're replacing an electric hot water heater tank and you're doing a 55-gallon or less, there's a $600 rebate on the hot water heater. If it's a larger heater or you're not replacing an electric heater, it's going to be less. There's a mass CEC, what they call a whole home air source heat pump pilot program. This is worth $2,500 and an additional $500 if you do something called a blower door test. And there are some increases in this for low to moderate income households. And this is specifically for people who do a whole home heat pump system replacing a gas heating system. Then there's what we call a mass save renovations and additions program. This is for what we call a deep energy retrofit, where you're doing your whole house, and that's worth up to $10,000. There's also what we call alternative energy credits, or AECs. These are going to be useful if you're doing your whole house and you're eliminating all fossil fuel heatings. These are credits that are paid over 10 years, but there's a way to bring them all up front and collect all those payments up front. And they're worth somewhere between $1,500 and $3,000, depending on how big a system you're putting in. Finally, there's a federal tax credit. This is a one-time only credit. It's a lifetime limit of $500. If you haven't used it yet, you can use it for air source heat pumps, and you can use it for heat pump water heaters. So how do we get started? You already started today. We're getting educated and we're planning for the future. We understand that everybody's not ready to go out and replace their heating system or their hot water tank today, but you will at some point. And so by getting educated today, we're building for the future. We're building knowledge for the future. And if you want to get started, consider getting one of the free Mass Save Home Energy assessments. And they're probably going to recommend additional insulation and insulate to the extent that it's practical for you. Now, we are here to help you. I'm a HeatSmart coach. We have other HeatSmart coaches in Newton. We have an email address here. If you have questions, email us. We'll get back to you. If you want us to call you, leave your number. We'll call you back. If you don't have access to a computer, we have a hotline number. Call the hotline, leave your phone number. We'll call you back and get your questions answered. We also have a website that we just launched. Please go onto our website. You'll find additional information, and we'll be adding to the information on that website as we go along. And if you don't feel like copying it down right now, you can just go to the Green Newton homepage. There will be a link to the HeatSmart website from the Green Newton homepage. And soon we'll have a link on the city's website to this as well. Finally, consider when we get them to use the HeatSmart Newton vetted installers. That's kind of a peace of mind thing. You will be using a trusted installer that we've vetted and we know they're going to do a good job for you. Finally, before I end, I want to introduce a new software tool that Green Newton has developed along with other volunteers, and it's called the Take Action tool. And we have this tool available on the Green Newton website. It's a great way to get involved in reducing your climate impact. It gives you information about actions you can take. It tracks actions that you've completed, and it details the rough amount of carbon emissions you've reduced. You can even set up neighborhood groups to have a friendly competition to see which neighborhood can take more actions and reduce climate impact the most. And it will give an overall tracking of all the Newton households and how we're doing. In order to get into this tool, go to our website, greennewton.org, and you'll see a Take Action link. Click on that link. You'll be able to set up an account with an email, password, and zip code. And at that point, you'll be presented with many actions that you can take. Some of them are relatively simple, like starting a compost pile. Some are bigger projects, like changing your heating system to a heat pump system or doing a solar installation. But whatever you do, you can log it in here. You can check things off as you complete them, and you can create a to-do list of things that you might want to do later. That's kind of the end of my presentation. I'm going to throw it now to Bev Craig, and she can maybe give us some questions that have come in.
Sure. Hi, everybody. Lots of great questions today. And one of them was from Stephanie Rogers, and it's really for Phil. It's about, she wanted you to elaborate, Phil, on dehumidification of heat pump water heaters. You mentioned that sometimes can dehumidify a basement.
That's correct. In essence, in the process of taking heat from the room and bringing it into the heat pump, in essence, it will dehumidify the area around the heat pump where it operates. And so you get a dehumidification effect as a result of operating the heat pump water heater.
I'd just like to add that heat pump heating and cooling will also dehumidify. So if you're running a dehumidifier and you install a heat pump heating and cooling system, you can unplug that dehumidifier because you won't need it.
And another question Ted Chapman asked he was asking, how do heat pump systems integrate with forced air, hot air systems, and with existing hot water heating systems?
That's a tricky question. Generally, it depends. If you're talking about mini splits for dealing with individual area or space conditioning, and that's not really a problem in a sense that you can add a mini split to any room that you'd like to. You do have to have some caution about where you're taking the set point for, oh, I'm sorry, you can't see me. Where the set point is for the thermostat is for the central air conditioning system, because depending on how you put in, where you put the mini split, you could affect the.
Oh, we lost Phil.
Why don't we just keep going and he can keep filling in when he gets back. Barbara Cannon asked, what process will Newton HeatSmart use to vet installers? And when would you guess that this list of trusted installers is going to be available?
Yeah, I can answer that one. The process is done in conjunction with the Mass CEC, the Clean Energy Center. They are the ones that send out the RFPs, the request for proposals, to all their contractors that they have on their list that are involved in rebate programs. And they have probably 200 contractors on their list. Now, every contractor is not going to necessarily they're not going to necessarily want to be a provider of this, because many heating and cooling contractors are small companies. But hopefully we will get, at least a half a dozen or so responses, and we will have a chance to sit down with the professionals at the Mass CEC and a committee of HeatSmart Newton citizens to actually interview them, ask them about their experience, ask them how they present their proposals to people, ask them how they can help Newton by taking part in, say, public education forums, joining us if we're out at a village fair or at farmers market, and just helping to educate. So the vetting process is a very kind of rigid process that the Mass Clean Energy Center does to initially get the contractors to make proposals. And after that, then we have the chance to sit down and pick the ones that we think are the best fit for the city of Newton. When will it happen? Well, we would have liked to have been able to announce them tonight, but due to the pandemic, we just can't do that. In fact, the request for proposals hasn't gone out yet because many of the contractors just aren't able to do that right now. We hope to have those proposals going out in the next couple of weeks. It's probably going to take 3 to 4 weeks for them to all come back in. Then we'll review them. So we're probably talking about around 2 months before we have specific contractors to recommend for you. Now, there's no reason you can't go and use a contractor if you have one, especially on a heat pump water heater. Any plumbing contractor that you use is very capable of installing a heat pump water heater. The heat pump heating and cooling systems are a little trickier. So you'll have to wait about 2 months probably to get those recommendations.
So Ken Mallory is asking, for heat pump water heaters, do you need a separate outdoor compressor like the heating and cooling heat pumps?
Right, you don't. The heat pump water heaters have everything built in. On the top section, they have the actual heat pump, which is almost like a mini air conditioner. It's built into the top of the heat of the tank. And the bottom section of the tank is where, of course, the water is held, and they have an electric heating element down there to make it the hybrid system. But everything is built in. There's no outside component, and you can configure them to run as a heat pump hot water heater all the time, or you can have them run as a hybrid, or you can have them run even all electric if you want, although there would be no reason to ever do that.
So Helena Brown has asked if we could compare the cost of heating a house using gas or heat pumps at today's prices of gas and electricity. So that's extremely specific to the house. It's really hard to know that. The average, I know statewide, the average heating cost, excuse me, is $2,500 per year. I think most Newton homes are bigger than that. But if you went from a gas system on that average, you might be adding around $500 or so a year. Again, it's how the more insulated your home is and air sealed, the lower that cost differential will be. And there is the issue, the gas is at an unprecedentedly low price right now, and electricity is fairly high. In 5 years, 10 years, there's not likely to be that same gap. Excuse me. Tim Walters asking, if one has used the federal tax credit for solar PV, does the heat pump federal credit still apply?
Yeah. Solar photovoltaic installations have their own federal, it's not a federal tax credit, it's actually, you're right, it's a federal tax credit, and there's also a state tax credit. But those don't count against your lifetime credit for that we talked about in this program. Those solar credits are a separate federal program, and those credits are going to drop significantly at the end of 2020 and will phase out over the next couple of years. So now's a good time to think about solar if you're able to do it, and we can certainly help you with that if you want to send an email to Green Newton.
Excuse me, I just want to say that Phil Hanser is trying to call in, and if there are any questions that cannot be answered during this Q&A, that if we can still keep the questions and answer them by email, and also post them on our as a follow-up in our e-news bulletin. We'll do the best we can.
Karen Sontag is asking, does it make sense to install one mini split on one level of your house just for air conditioning? I have a fairly new efficient oil burner and don't really need the heat except as backup. And is this something that can be accomplished this year before it really heats up?
Absolutely. And as we really start to see the effects of climate change, more and more people are finding that there's rooms in their house that are just unbearable in the summertime, and they would really like to air condition them. Heat pumps are a great way to add air conditioning. They're quiet. They're much more efficient than a room air conditioner. You don't have to lug a room air conditioner up from the basement and put it in the window. So it's an absolute great way, great application for a mini split, and that's done all the time.
And I will add, it's compared to central AC, it's much, much, much cheaper. And the other thing is if you do add it for air conditioning and use it for that level for heating, I mean, it depends on how zoned your home is, but if that level has its own zone, you can let it heat really late into the, in the shoulder season, so in the fall and early in the spring, and minimize how much oil you're using, then turn on that zone when it gets really cold so that you're not running the heat pump at the lowest temperatures. So that's one way you can do a partial system and still reduce how much fossil fuel you're using without completely replacing the whole system. John and Karen Sloat said, we have a ducted AC system. When a company came to tell us about heat pumps, they said they couldn't use the ducts. Is that common? Would we be able to use our AC ducts for heating?
Phil, do you want to take that one?
I'm sorry. Say it again.
Oh, yay, welcome back.
Yeah.
I'm sorry.
The question was if they have an existing ductwork for a central AC. Well, I'll answer it. Phil's gone again. Ductwork for central AC can be of two forms. There's these little tiny high pressure ducts that some people have. Those would not work for a heat pump. But if you have a more conventional, which are large, rectangular ducting, and you see these in your attic and so forth, those can typically be used for a heat pump heating and cooling system. Now, it kind of depends on what condition they're in and how tight they are. But in general, yes, you can take ductwork that's used for a conventional AC as long as it's not that high pressure type, and use them for heat pump heating and cooling.
So Francis LaMonica is asking, can heat pump technology be coupled with geothermal? And actually geothermal really is the same thing as ground source heat pumps are the same thing. So basically a ground source heat pump system or a geothermal system is using the more constant temperature of the ground, which in Massachusetts is around 50, maybe a little higher than 50 degrees, just 10 feet down. And it's using that. That's why it's even more efficient than air source heat pumps, is because it doesn't have as much, it's like a more stable temperature that it can move from. Ground source heat pumps are a great solution for a lot of homes. They tend to be especially good for new construction. They are more expensive. They do pay back, and actually the incentives are quite good right now. They pay back faster, they last longer. They can also heat your hot water. So there's a lot of advantages to that too. But I think for more retrofit situations, more people tend to use air source heat pumps. That's why there's hundreds of thousands of them already in Massachusetts, so many in Vermont, Maine. It's because it's a really good fit for retrofits.
And I might just add that when the Newton HeatSmart Newton program decided which technologies we wanted to offer, we didn't exclude ground source heat pumps because we didn't like it. It's a great technology. It's just that it's a little more invasive because you have to have a drilling rig come out and drill a very deep hole in your property, and it's more expensive. And we just felt like, as we're getting started with this program, that we would offer the air source heat pumps and the air source hot and just not really offer the ground source. But they're great technology, and if you can do it, you should definitely look into it.
So Ellen,
Hi, I'm sorry. I'm back. I apologize without visuals, so my apologies.
Welcome
It's
back.
all right. Good to have you back.
So Ellen Fisher she says, our neighbor has 2 large heat pumps between our houses. So we're very aware of how noisy they are. How can we find out how noisy or quiet a new system would be? So I suspect the 2 heat pumps that you're thinking of are actually air conditioning compressors. Air conditioning compressors tend to be, I mean, depending on how big they are, they're often 80 decibels. Air source heat pump compressors tend to be about half that. So if you're going for air conditioning and you want a quieter option, usually air source heat pumps are better. You can certainly look up, like if you have an installer in and they'll recommend a particular size system, you can look up the decibel levels on the cut sheet. They can easily give that to you. So that's what I would recommend. And by the way, decibels are on a very different scale. So 10 up is quite a lot. It's not like just gradually more loud, it's a lot louder. Should we expect that a heat pump installer can determine if there are any refrigerant leaks a year or so after installation? How common are leaks after years of operation?
I mean, from what we know, if the installation is done correctly, you shouldn't have leaks years after the installation. They have to take care, and it's a little tricky to pull, but they have to pull a vacuum, and this takes time when they're doing the installation, and that's really part of our vetting process. We want to make sure that the installers that we choose are going to know how to do it right and will do it right, so that you won't have problems with leaks, and there shouldn't be problems with leaks.
I mean, generally, the biggest issue is, frankly, at the installation, as Craig is pointing out. The most typical problem with these units is that moisture gets into the pipe that's conducting the refrigerant. And there are some simple procedures that allow you to make sure that that doesn't happen. And generally, the refrigerant is not the kind of chemical that eats away at the pipe itself, and so it doesn't tend to damage the pipe. So post-installation leaks are relatively rare. The larger problem tends to be that at the initial installation, there's moisture in the pipe, and that reduces the efficiency of the unit and may actually disable the unit. So the trick is to have that initial installation done correctly.
So Tim Walters asking if the external unit, the compressor, is wall mounted, can it cause a vibration problem? And yeah, I mean, that can be a problem, and wall mounting is not the optimal place to do it. However, there are a number of rubber gasketed products to try and minimize that. I do know, like, I've seen, in my day job, I've seen about 200 installs, and the only noise complaints we ever got from any of the people was when it was wall mounted. In those cases, they did retrofit them with these gaskets, and they didn't have problems after that. But it's definitely something, again, like the installer is really important. You want to make sure that they suggest the best place for you, and that's not going to be a risk for you. And if they do wall mount, you want to make sure you put in the right protective equipment.
And I think that we see probably in New England, many of the compressors will be mounted on maybe on a 20 to 30 inch stand with 4 legs off the ground. They won't be physically attached to your house. If you get a mounting like that, they'll be free of the snow and they won't be physically attached to your house, so you shouldn't get any vibration.
And then there was a question about seniors and payback for solar and heat pumps. And actually, you know, solar, if you are retired and you don't have a generous pension of some kind and a lot of like investment income, you're fairly likely to qualify for the solar loan program through Mass CEC that provides a 30% subsidy on top of tax rebates because of your income is not that high. Even if you have a lot of assets, that can definitely be the case. And if you qualify for that, the payback on a solar system is usually between 4 and 5 years. Of course, you have to check out your particular roof and make sure that's true. But the payback that would mean you would have, a good 20 years of free electricity. And maybe you're going to sell the home around when it pays back. As long as you hire a real estate agent that knows the real estate market and how to sell solar homes, the research shows that generally translates, that free electricity in the future translates into a higher purchase price. So the key thing is making sure your real estate agent is educated, and there are continuing education classes through Mass CEC called Sell the Sun for real estate agents. They're very popular in Massachusetts, but certainly you want to hire someone who has that education. On heat pumps, I would say if you're a senior and you have window ACs, a lot of times you might be hiring somebody to put those in and out. If it's a bunch of them, that can add up pretty quickly. So having a unit that you don't have to change in and out might be worth the $4,000, over a period of time, just to avoid that in and out every season. And it does also translate into, you've got some central air then, some indoor air that's not just temporary window AC. So you might be surprised with the 0% heat loan, the tax credits. It can be a good investment even for a senior. Somebody was saying, I find forced air heating systems make my house very dry. Is this the case for heat pump heating? Is there a way to humidify the air with heat pumps?
There's not, any heating system will tend to dehumidify, and so air conditioning systems. I think it's somewhat less for heat pump systems, only because typically you're not trying to heat the entire home in some uniform way, and so that you don't dry out the entire house at the same time. But any cooling or heating system will tend to dehumidify the air, and I would guess probably less so for heat pumps. Depends on how the system is configured.
And so one last question, and then I think we're nearing the end of our time. Tim Walter's asking, is there a limit on the number of contractors that HeatSmart Newton will be recommending?
Yeah, we have a goal in our application to have 2 partner contractors or installers for heat pump heating and cooling, and 2 partners for heat pump hot water heaters. Now they could be the same or they could be different, because any plumbing company can do a hot water heater, but a heating system is more specialized, and that takes a heating and cooling company. So our ideal would be to find 2 installers for heating and cooling and 2 installers for hot water heaters.
Thank you, Craig. Bev, that's it for questions, would you say?
Yeah, I think there's some others we can answer after and make sure to send out the answers. But it's been a great discussion, and thank you everybody for joining.
And I'd like to thank you, Bev, for answering the questions, and to Craig and Phil doing terrific presentations. Everybody for joining. Please do not forget really to go to Green Newton's website and do the take action tool. Please use that, because it helps us to keep track of what people are doing to make a difference to bring down our greenhouse gas emissions in Newton. And I'm curious to know how people learned about this program. One of the things that makes our programs a success is getting the word out to the community about opting up to 100% renewable, heat pumps, solar, the home energy assessments. And so we do have our e-news bulletin. If there's anyone on here who does not get the e-news bulletin once a week, please let us know. It's full of information every single week. And also, just get in touch if you want to participate more in our programs. We're still very active. This pandemic is not getting us down. It's actually the best therapy that you can do, to know that you're doing something positive. And even if you don't have a whole lot of time, even though we're all at home, a lot of people still finding ways to keep very busy. but you're all on here
Meeting?
because obviously you care about the environment. And so whatever you can do, we welcome your support. We welcome your past support, and we just hope that you'll continue to go with us into the future to make a difference. We will have a recording available as soon as we can figure out precisely how to share it. I think we know, but give us a little time. And we'd love your feedback, and just stay safe. And you're all wonderful people for joining this. Again, thanks to Craig and Phil and Bev, did a great job. We're going to try and hold more webinars because part of Green Newton's mission is to inform the community about what they can do to make a difference. Okay, so this is it for tonight, and hope we made it an interesting evening for you.